All right. So.
I said like that.
All right, so good news about these ones is that they can be simplified at all. So we have our angle theta here, our opposite side, our hypotenuse, and then our adjacent. Whoops, I kind of made that into a. So opposite over hypotenuse for sine is 5 over 13, and then again, just when I would be doing this for homework, I would just write these 6 down right away in the same order, the same don't mix it up to confuse yourself, just get in the same pattern that now this just flips over. Obviously, if I asked you a cosecant, hopefully that you could translate that back, that you wouldn't have to write all 6 down, but just that you get that they go together. So then adjacent over hypotenuse, so then flip it. And then tangent is opposite over adjacent, and then flip that. Okay. All right, so flip the page over when you can. All right.
Yeah, just 3 more.
Let's get one more example of it, you guys. We can do it announcements and stuff.
Can we go outside this room?
Right in Hatcher's window.
I got check how many inches are out there for
Oh, okay.
It'd be funny if we just stood outside his room.
Canadian.
Okay, guys. All right. So, guys, this next one, why is this one's a little bit tougher than the one we just did?
Because we don't have the hypotenuse.
We don't have the hypotenuse, and there's a square root involved. So, there's a couple of different things going on here. So, we have to find our hypotenuse. So, we're going to have to find this. However, this is where it gets a little bit tricky as well. They want it in simplest form. So, that means I don't want decimals. So simplest form means I want it in exact values, instead of the exact values, but in simplest form. So we're going to have to kind of work a little bit with some square roots here. So we're going to first find our hypotenuse, which we can do using Pythagorean theorem. So x is the square root of 12. Now, is that simplest form? No, it's not. Okay, and then, so we're finding square root of 12, but we want to simplify that. So what are we going to do with square root of 12? Make that what? Square root of 4, square root of 3, guys. So this will be 2 square roots of 3.
Is that allowed?
Is that allowed? Yeah, we actually like it that way as much as we should. We probably don't really like it that way, but math people like it that way. So we're going to do our side, all these different trig ratios, but then we have to simplify it. So like our warm-up asked us to, we have to simplify it, which means we can't have that radical in the denominator. So when I'm talking about the sine opposite over hypotenuse, I'm going to have square root of 3 over 2 square roots of 3. All right, opposite over hypotenuse. So what does that become?
1/2.
Becomes 1/2. Those square root of 3's just get to cancel. So this is just 1/2. All right, so what's the cosecant going to be then? It's going to be 2. 2 over 1 or just 2? Okay. Why don't you guys see if you can do cosine and tangent, and then the other ones as well. I'll give you guys a second to try before I explain it. And after I explain this example, we can take, even though we've had a few breaks, we can still take one.
Wayfair, that's not sure.
Oh no, that's a hotel.
No.
Yeah, Wayfair. Yeah.
No,
Wayfair. Wayfair. What is Wayfair?
Wayfair's the place where
You
buy
like order
furniture.
like furniture.
Yeah.
I thought it was a hotel thing,
It does kind of sound good.
like Trivago or
Wayfair you always hear about on TV because like all the TV like designers use Wayfair. Just would you? Yeah, it's pretty. Mrs. Miller just ordered from Wayfair. That's actually one of the things she was asking me about when she came in during her test. She was ordering something online and she was asking about your reaction.
No, we should go.
Yeah, it was like pillows and curtains, and she was asking me what I thought. I was like, thank goodness you're working so hard. Like, hey guys. You guys for cosine, we're doing adjacent over hypotenuse. However, we can't leave it this way. So again, going back to our warm-up, what do we need to do with that? By square root of 3.
Do that.
Over
6.
2 times 3, which is 6.
Let's go.
But is that simplified?
No.
Yes.
You gotta.
The 3 over 6 can still be simplified.
Oh.
Divide them both by 3.
So that would be 1 over 2.
1 square root of 3 over 2 would be this cosine here.
You can do that.
I love all these. We can do that. Yep, we can. Yep. So you can simplify the 6 over 3, but that square root of 3 is kind of on its own, so you can't cancel in there. So square root of 3 over 2. Now, I think flipping this one would not be as smart. I'm going to go back to my original to flip that. Does that make sense? Because if I flip the 2 over square root of 3, I'm going to have to rationalize that. I have to get that radical out. But if you guys remember, if we go back a little bit here, this is what we started with. So secant is technically the hypotenuse over the adjacent. So actually, kind of going back to the original makes this one a little bit easier. That makes sense? Now, you would get the same thing had you done this one and flipped it, but it's a little bit faster to, like, so kind of being strategic with it. And then tangent is opposite over adjacent. So square root of 3 over 3. And then we're going to flip this. But I can't leave that radical in the denominator.
Whoa, slow down there.
Yeah, it looks pretty happy.
What?
It looks happy down there.
All right, what can we still do, you guys?
I don't know. Oh, divide into 3s.
Yeah.
So then it just equals. Let's go.
All right.